So the other day when we took notes on the few properties of algebra that I want you to know this year, commutative, associative, multiplicative identity, and additive identity, I left off one important property, and that's called the distributive property. So again, we're going to be focusing on justifying those results today with another property. So the way I wanted to start this today is by something that hopefully should look familiar to you, because I am told that area models are used in elementary school. So if, for example, I've got this rectangle and it's split up into two smaller rectangles, rectangle A and rectangle B, I know that the length of this side is 5. I know that the length of this side is 11. And then the height of the entire rectangle would be 8. And if I know that this height is 8, then I also know, right, this height is 8. So I'm going to write that in just in case. So when I'm finding the area of rectangle A, right, I'm taking the length times the width. That would be 5 times 8. And that would be 40. When I'm finding the area of rectangle B, I'm taking the length times the width, which is 8 times 11, and that's 88. Okay, so if I'm trying to find the total area, right, I see two individual rectangles, A and B, right? So I see the area of rectangle A is 40. We already found that. And I see the area of rectangle B is 88. So I can write it like that. And if I'm finding the total area, that would be combined. 40 plus 88 is 128. Now, I could have, though, not looked at this as two separate rectangles, and instead looked at it as one giant rectangle. And that big rectangle has still a height of 8, but when I think about this side, right, if it's broken up into 5 and 11, that means that the total side is going to be 16. So I could have just said 8 times 16, which also gives me 128. The reason why I start with this area model is because this is a really good way to visualize what's actually happening when we use something called the distributive property. Okay, so I'm weirdly going to start with this visual example over here before we even define what the distributive property is. So similar to me saying that finding the entire area of this pink rectangle up here is 8 times this whole big length, which is 5 and 11 put together is 16, I'm looking at an expression like this, where I see there's a 2 on the outside, and inside the parentheses, I've got an x plus a 6. Now, using the order of operations, I can't really do anything here because we don't know what x is. And then when I think back to earlier, and I think, okay, well, we also learned about combining like terms, but inside the parentheses here, I see an x plus 6, and those aren't like terms. So I can't really do anything with this expression right now. But I do see that I've got this 2 on the outside multiplied by 2 things on the inside there, and that's looking really similar to this 8 on the outside multiplied by these 2 things that I combined to be 16. Okay, so I'm going to set it up this way. So I'm going to pretend that this 2 is like that 8 in the previous example. And so that's going to be the height of my rectangle. And then here I've got the first part of that bottom side, and then I've got a positive 6. So unlike that pink rectangle above, I can't just say x plus 6 is 16, for example, because we don't know what x is. So we're going to have to go with the method in which we break up into smaller rectangles. So when I think about rectangle A, I find the area by taking the length times the width. So that would be 2 times x. In rectangle B, I take the length, which is also 2, by the width, 2 times 6. When we were doing this broken down process before, right, then to find the total area, I did have to add them together. So I'm going to add them together also. Now, we know that 2 times 6 is 12, but I don't know what x is, which means I don't know what 2 times x is, which means it's just going to stay 2x. Now, notice that my answer does look very similar to the original problem, right? I see a 2, I see an x, I see a 12. The only thing missing from this original problem is the 12. But if you can kind of visualize this 2 multiplied by the x, the 2 multiplied by the 6. And that's what's going to happen in every single distributive property problem we see. So when I say the distributive property, what I really mean is, symbolically, if we have something, and I'm going to say A, and that's multiplied by an expression inside a set of parentheses that's separated by a plus or a minus sign, then what I can do is, instead of writing it as 2 pieces of things being multiplied, I can distribute this A and multiply it by both pieces. A times B, and then I'm finding the total, A times C. Now, if I had to guess, symbolically, you're looking at that definition and you're like, Miss Powers, what the heck are you saying? Let's look at another example. So I want to use the distributive property on this expression. So let's write that down. 4 times h minus 7. Okay, so I know that this problem is going to be using the distributive property because I've got something sitting outside of parentheses that's being multiplied. And when I look inside the parentheses, I've got more than just one thing, right? I don't just have 4 parentheses h, right? Because that would just mean 4 times h. Here, the 4 is being multiplied by 2 different things, an h and that minus 7. So I can kind of draw out my visual here. 4 is how tall this is. H is that length. And remember, we read math from left to right, so that negative 7 would get attached there. So when I think about the area of this first rectangle, that's 4 times h, which makes sense. That's the first piece, 4 times h. And when I think about the area of this second rectangle, that's 4 times negative 7. To find the total, I need to add them together, right? My total is always adding things together. So 4 times h is 4h, plus sign in the middle. 4 times a negative 7 is a negative 28. 4h and 28 are not like terms, so we would say that this is the simplified expression. Let's look at one more example. So I want you to write negative 5 times m minus 2. Things start to get really weird in algebra because, unlike our really beautiful example with all the numbers up here, we've got negatives, and negatives make things complicated and a little bit harder to visualize. But I still want you to be visualizing what's happening here. So negative 5 is going to be the height up there. We've got an m, and we have a negative 2. Okay, so finding the area of this first rectangle is negative 5 times m. Finding the area of this second rectangle is negative 5 times negative 2. We always find our total by adding the two parts together. So let's see here. Negative 5 times m is a negative 5m. Negative 5 times a negative 2 is a positive 10. So one thing that's pretty crazy about the distributive property, I want you to take a look at example 1 and 2 here. So here I started with a positive 4 on the outside. There was an h and a minus sign with the 7 in the inside. When I distribute that multiplication, notice how I end up with a plus negative 28. So there's still that minus sign represented there. In this other problem, I have a negative 5, right? And then I've got an m and then a minus 2. So we've got a lot of negatives happening here. But when we think about it, right, the negative 5 and the m, when they multiply, I'm still getting a negative result. But here I've got a negative 5, and I'm going to be multiplying it by that negative 2. It kind of explains why this 10 is totally positive. Okay, we've done this before. We'll do it again. I want you right now to pause the video and try these. Try these problems. After you pause and try these problems, then you can push play again and see my solutions. Okay, hopefully you have paused. So whenever I'm doing the distributive property, I tend to not use the visual example, but if you like the visual example, you can still set it up. I like to use the two little loopities to remind me that this 4 is being multiplied by everything inside these parentheses, right? So if it's being multiplied by everything inside the parentheses, the 4 needs to multiply by the h. The 4 needs to multiply by the 7. We find our total by adding. So 4h plus 4 times 7 is 28. Let's look at the next one. So negative 6 needs to multiply by both parts. So negative 6 times x, and then negative 6 times 5. We find our total by adding. Negative 6 times x is just negative 6x. Negative 6 times 5 is a negative 30. Simplified. Last but certainly not least, negative 2 times k, negative 2 times 10. So I've got a negative 2 times k. And remember, this is one of those tricky ones. We read math from left to right, which means that minus sign attaches to the 10. So what I really have here is negative 2 times a negative 10. Find our total. So negative 2 times k is just a negative 2k. Negative 2 times a negative 10 is a positive 20. Answer.